I'm speaking for everybody now. Oh, and also today is my golden retriever's 2nd birthday. So super fun day. We're kind of super low on attendance today. So far, at least. We've only got 9. That's okay. We're recording. All right, guys, so let's get started. I am now going to share screen. And I have a notebook paper set up for us. Okay, so you should see that. Okay, so guys, remember last time on Monday, we looked at finding absolute extrema. So extrema, guys, that just means absolute min or max. But we were on a closed interval. So we knew it was a closed interval because it had brackets. And when we are on a closed interval, we treat everything a little bit differently. Remember, we found any critical points in the interval, we tested those, and we tested endpoints, and we put it all into the original function. Basically, we were just finding all these y values and comparing them to see which one was the largest and which one was the smallest in that closed interval. So guys, what we're gonna do today is check out absolute min and max on open intervals. And you might not, you might not think that it makes a big difference if your interval is open or closed, but it really does, guys, because it makes a big difference about what's happening at your endpoints. You guys have to shut it. I can hear everything you're doing. Sorry. Okay. So I have a picture drawn for you here, and I've got some intervals on it. And notice my intervals are open, and the way I know that they're open is because they have parentheses instead of brackets. So for both of these cases, I'm looking at 2 different intervals on the function, and both of them are open. So you guys, before I start really delving into this, we need to remember what it means to be an open interval. You can, for example, this one here. We're going to be on the interval from 1 to 7, but the 1 and the 7, while they bound your interval on both sides, they cannot be included in the interval. So it's more like saying my interval is between, everything between 1 and 7, not starts at 1, ends at 7. So it's everything between. And let me notate where this interval lies on our graph. So notice on the graph here, I have x equals 1 marked, so that would be about here on the function. And then x equals 7 is right here. So this is the interval that I'm looking at. And just like we did on Monday, I want to know absolute max, absolute min, you know, whatever I can find in here. The thing is, because I can't consider my endpoints, I might not have any absolute extrema in my interval. And if I do, I'm more than likely only going to have 1. So it won't be a max and a min, it'll be a max or a min. So let's see, I need a color I haven't already used. I'll try this one. Okay, so you guys, I first want to note, you can see that there's a critical point in this interval. And that critical point, just by looking at the picture, you can also see that is the absolute lowest point in the interval. And you guys, so at this critical point, we would absolutely have an absolute minimum. But while that's easy to see, finding an absolute max on this interval is a little different, and it might look to you like we have one. So you just say, oh, you just find the highest point on the interval, right? So I can't include the 7 though. So say, okay, well, that's fine. We'll just get really close to it. Maybe here, where x is really close to 7, maybe it's like 6.9. Say, yes, definitely, that is the highest point. X is about 6.9. The y value is about right here, highest point on the interval. Well, is it though, you guys? Because I think I could come in and get a little closer to x equals 7. What if I come in and say, oh, but you know, I could get a little higher by doing x equals 6.99. And that would just be just a little bit higher on the y-axis. Parker, you're gonna have to turn that sound off. Sounds like a war zone in here. Okay. And then somebody else is like, no, I can get even closer. You guys, I could do 6.999. I'm so close to 7. Surely that is the highest point in the interval. But you guys, because we can't just get to the 7, because we can't just say, hey, x equals 7, it's the highest point. Because I can approach it, but not reach it, I can get infinitely close. So even if you think x equals 6.999 is the highest you can get in this interval, you can always add another 9. You can do that forever, guys, which means we actually don't have an absolute max on this interval. Because if you think you're at the highest point, as close to that 7 as you can get closer. So each max is not a max because you can get higher. So basically what we're saying here is we cannot consider the endpoints or anything even close to the endpoints as an absolute. So if I can't consider the endpoints, remember last time on the closed interval, I had 3 possibilities for my answer. It either was a critical point or an endpoint. But if I can't consider the endpoints at all because of this, because it's getting infinitely close to this value but never reaching it, then the only places I can consider being absolute extrema are the critical points. So endpoints are out now. They've got parentheses. That means they're not included. So only critical points. Keep that in mind as we look at the interval, the second one I have here in green, that starts when x equals -6. Let's say that's about here. And it ends when x equals -2. So let's look at this little portion of the graph. As you go along, I see that there is a critical point in my interval. It's right here. You can always tell where critical points are by looking at a picture, remember, because it's where the graph reaches a high or low point and then changes direction. So here's a critical point in my interval. This time, look, it's the highest point that we have. So it would be an absolute max. So we definitely have an absolute max, but we don't have an absolute minimum. Because again, you might think it's down here somewhere, but you can't specify. You guys, you can't specify that that is the lowest point because I can always find a lower one by getting just a little bit closer to that x equals -6. So notice in both of these intervals, the only extreme values we had occurred at critical points. And that's good news for us because it's going to make problems easier. If you don't have to consider your endpoints, all you have to do is find critical points, which is just like the stuff you did in the sections before. Okay, hold on, you guys. Birthday girl is chewing something she's not supposed to be chewing, and it's super loud. It's going to drive me up the wall. Grace. Grace, come here. Girlfriend. You know better. No answer. I don't care if it's your birthday. You can't be chewing on plastic. Okay, sorry guys. I'm back. Okay. So we only have to consider critical points. Now, here's a question. What if, let me make another interval. I need to erase a little bit. Actually, you know what? I don't need to erase too much. Let's make an interval. I've got this red up. I'll do an interval in red from here to here. You guys, let's say the interval in red is from 5 to 9. Now, I know the point at 9 would be somewhere up here, and that's, you know, it's no big deal. But the point at 5 would be right here. So guys, look at the interval from 5 to 9. So kind of ignore, I can't erase too much because it'll erase my whole function. I figured that out. But let's think about this interval here from 5 to 9 on this function. If I asked you if there was an absolute min or max in this interval, what would you tell me, guys? Because I can't say anything about the points at 5 and 9. And notice there's no critical points in my interval either. So in this case, because there are no critical points in the interval, there are no absolute extrema in this interval. So depending on what your interval looks like, you might have cases where there's none. And it just means that there was no critical point in your interval. So I've got some problems set up here, and I want to work them. So let's start with this one on the left side. So this one right here. I've got f of x equals 2x cubed minus 3x squared minus 12x plus 1. And the question tells me to find any absolute extrema on the open interval from 0 to 4. So you guys, open interval, closed interval, no interval. You guys, my first step is the same for all of chapter 12 so far, right? Take the first derivative. You guys, these few sections are really fueled by critical points, right? I have to find them for every single problem, it seems like. So how do I do it? Well, I find the first derivative, which is 6x squared minus 6x minus 12. And what do I do with it? I set it equal to 0. Now, there's a bunch of 6's or multiples of 6's in this, so I'm going to go ahead and factor the 6 out to make my factoring easier. And I have x squared minus x minus 2. Okay, so let's continue factoring. So I do have the 6 on the outside, but remember, because it doesn't have an x in it, it's really not affecting your factors at all. Okay, so let's factor x squared minus x minus 2. I think it's going to be x minus 2, x plus 1. Where do I go from here? I need to set each of the factors with an x in it equal to 0. So I have x minus 2 equals 0, and I solve for x, and I get x equals 2. This is the location of one of my critical points on this function. Now, where's the other one? It's at x equals -1. So it all seems pretty normal, right? We've done this before. And you guys, for the most part, it really is just like you've done before, finding and classifying critical points. But because I have an interval, I need to make sure that any critical point that I actually consider as my answer lies within the interval. So it has to be between 0 and 4. So you guys, this x equals -1, that's not between 0 and 4. So I can't include it, and I'm only looking at 1. So this x equals 2. It is a critical point in the interval, which means it is going to be my answer. But I have to know if it's a min or a max. So obviously it's not both. But in my answer, I need to say there's an absolute min or there's an absolute max. So once you're here, you found the critical point that's in your interval, you're disregarding the other one, you do need to test it. You guys, remember the easiest way to test a critical point to see if it's a min or a max we found is in the second derivative test. So I'm going to go ahead and find the second derivative. Remember, you just take the first one and take the derivative of that. So I end up with 12x minus 6. Take your critical point in question and put it into the second derivative. So you're going to do second derivative at 2. So that's 12 times 2 minus 6. 24 minus 6 is 18. So I found my value. Remember, I'm concerned if it's positive or negative. Well, it's positive here. And remember, positive goes with the word up. So positive second derivative means your graph is concave up there. So it's in this shape. If that is the shape of my graph at this critical point or around this critical point, what does it mean? Well, it means that this critical point is a minimum. So remember the second derivative test. If you put the value in and it's positive, it means that point is a minimum. So I know that seems a little backwards, but if you draw the picture about what that positive is meaning, that it's concave up, then you can see in a picture that it's a minimum. Now, it's not just a minimum or a local minimum. Remember, we're on an interval, so I can actually say there is an absolute minimum at the point where x equals 2. You guys, they're probably going to ask for the value of that minimum. Remember, if it says what's the value or what is the minimum, whatever it says, you're looking for the y value there. So what's the value of the minimum? Remember, there's only one way to find a y value, and that's to put it in here. So you guys, to find the value of that minimum, you would do f of 2 in the original function and find that y value. So you would just find f of 2. Now, what if they ask you if there's a max, an absolute max? Well, I only found one critical point in my interval, and it was a minimum, which tells me there is no absolute max on this interval. So notice how similar that was to what we did in 12.2. Let's see, find critical points, test them in the second derivative so we know if they're a min or a max. The only difference is we had to consider your interval and we left out that other critical point because it wasn't in there. But other than that, yeah, basically the same stuff we did before. So open intervals seem pretty nice. We don't have to do a lot of extra steps. Let's do the second example I have over here. So on this one, I want to find absolute extrema for this function, but this time my interval goes from 0 to positive infinity. So it's a large interval, but it doesn't really matter how big or little it is. You know, I see that it's an open interval. I'm going to find any critical points and decide which ones are in that interval. So if I need to find critical points, I need to find the first derivative. Sorry. So I'm going to get 3x squared minus 4x minus 4. And then I need to set that equal to 0. So 0 equals 3x squared minus 4x minus 4. And I need to factor this. Guys, on this one, we can't take that 3 out like we did over here with the 6 because, you know, they don't have 3 as a common factor. So we got to leave it in, and that's okay. We can factor this way. Just remember, think about factors of the first term, factors of the second term. You guys, this is a negative 4, so one of these will have to be negative. I'm going to put it here. And remember, you factor this however you want. My thought process that I've showed you before is I put these factors, and then I find the cross products. This is -6, this is 2. And then I add them together and I see what I get. Do I get -4? Yes, I do. So that means you have the right factors. So I write them down straight across. I get 3x plus 2 and x minus 2. Now that I've factored, same process as before, I set both of these factors equal to 0 to find my critical points. So you guys, this one, if you subtract 2 on both sides, you'll get 3x equals -2, and then divide by 3, you get negative 2/3. Over here, if you add 2 to both sides, you get x equals 2. Here's your 2 critical points. While my interval is large, I still need to check to see if my critical points are in it or not. So you guys, x equals 2, is that between 0 and positive infinity? Yeah. So I can use this one. But the negative 2/3 it's negative. So it's not 0 or bigger, right? So this is not in my interval, which is good because, I don't want to work with fractions if I don't have to anyway. So again, we're only considering the critical point at 2. What do I do from here? Test it. You guys, I need to find a second derivative. So what was our first derivative? It's right here, the 3x squared thing. So what's the second derivative? Well, that's going to be 6x minus 4. How do I test my critical point? I put it into the second derivative. So I get 12 minus 4. So I get 8. So again, this is positive, just like over there. Remember, positive second derivative means concave up, which means this value at 2 is a min. So, and I really didn't mean it to turn out this way when I picked these 2 examples, but these 2 examples have the exact same answer. There's an absolute min at x equals 2. Now, if you need the value of that min, obviously it's not going to be the same as the question before because it's not the same function, but you find the value by putting 2 into the original function if they ask for the value. And again, if they ask for an absolute max, there is none. You guys, the only way that you could have both a min and a max in your interval is if, for example, if both of these critical points were in your interval and one was a min and one was a max. Remember, you can't look at any other values except for critical points. Okay, so what I want to do now is I want to summarize 12.3 again. And I know I summarized the steps for the closed interval last time, but I'm just going to summarize again. Differences between open and closed. Make sure that you know what to do in each case. So for a closed interval, so bracketed, including endpoints. If your endpoints are included, just think to yourself maybe, if my endpoints are included, I have to test them. So what do I do on a closed interval? Well, I find the first derivative and I set it equal to 0. To find critical points, big kicker here, to find critical points in my interval. Remember, in 12.3, any critical point that's not within those numbers given, you don't have to do anything with. So I find my critical points that are in my interval. I test those critical points and the endpoints. So first of all, that's what I test. Where do I test it? I test it in the original function. Just f of x, that's where you put them. That's the biggest thing on the closed interval, and it's the only type of problem where we test in the original function. So you test them. After you test them, you just say the highest value for y that I found is the max, the lowest y value is the min. Remember, if it hits the high value or low value twice, then I just have 2, and that's okay. In open intervals, which we just did, you guys, definitely the better choice because it's so much like what we've been doing already. Open interval from A to B with parentheses. Notice the first step is exactly the same. Take the first derivative, set it equal to 0 to find critical points in your interval. Here's where they differ. You only test the critical points in your interval. Notice we're not testing endpoints. We really don't care about those. And where do we test them? We test them in the second derivative. We use the second derivative test just like we did in 12.2. Things to keep in mind, if you have a closed interval, you will always have both a min and a max. If you're on an open interval, you could have a min, that doesn't make sense. You could have a min, you could have a max, you could have both, or you could have none. Remember, it all depends on if critical points are in the interval. So yeah, your closed interval questions, you always are going to get an answer for both min and max. And then open, well, it's open, right? I mean, you might have one, you might have two, you might have none. But yeah, so those are the key differences that you want to have. You know, you want to have this written down, or just, you know, be very clear about the steps, because in 12.3, you have some questions that are kind of, you know, you have some closed and you have some open. If you've looked at 12.3 already, some of them are just pictures. You guys, if I gave you a picture, those were all on closed intervals. So you don't have to worry about looking at the picture and thinking, okay, are we including the endpoints or not? And it should be clear. It should be clear that they have brackets. Or there are some pictures, and don't let this confuse you. There are some pictures where it gives you a graph, and like it starts here and then it does some stuff and it ends here. And that's all there is to the function. You guys, as long as both of your ends are closed circles, that's a closed interval. So you just consider that as a closed interval. But yeah, so the pictures are closed intervals. And then you have some questions, some actual words like we did up here that are closed, and some that are open. You just have to know how to tell the difference. Now, that is all I have for you today. But before I let you go, on Friday, what we're going to do is we're going to do applications from these first 3 sections of chapter 12. So, you know, actual word problems. And the thing is, each section gave us a method that was a little bit different, and you have to know which one to use where. Like, when do I need the second derivative? When do I just need the first? You know, so we're going to go through those applications, and I'm going to help you decide which method to use, you know, and which steps to take, depending on what words they use, what intervals they give you, if they give you intervals, and stuff like that. So we're going to work through applications on Friday, and you're going to have a quiz that opens. Actually, I was going to open it on Friday. I'm actually going to open it on Thursday, a little early, because some people might want to just get it done. But you guys, you have a quiz that's open on Thursday. Don't feel pressured to take it on Thursday, because it's going to be applications like we do in class on Friday. So if you want to wait and work through problems on Friday before you take it, that is totally fine. And I'm actually not going to close the quiz until Monday night, not Sunday. So you guys, that means you have to get your homework done. That closes before the test or the quiz closes. My advice to you is to make sure you do finish all the homework before you take the quiz. I mean, because it's going to prepare you better. But the quiz is going to have some applications on it. So if you want to wait till Friday after class to take it, absolutely wait. If you're just feeling really good, you know, if this all just is easy peasy and you want to take it early, then take it on Thursday. But so that's the plan right now. So it'll be, let's see, homework. What is due this week? 12.2 part 2 is due this week, and 12.3. And then, so that's all the homework due this week. And then you'll have that quiz that's due on Monday night. And you get to choose when to take it, but it will open tomorrow. Again, on Friday, we will go over questions that you might see on the quiz. So I would definitely be here so you can be prepared. Okay, so I can't think of anything else to say. I know it's a little bit short, it's just 11:30, but that last part of the section just wasn't as long as the first. So I'm gonna let you go, and I will see you on Friday.